The domain of a rational function is a set of all real numbers that when substituted into the function produces a real number. What does that mean? Essentially, it means that every number that is plugged in will not give you division by zero. It can give you a positive, it can give you a negative, it can give you something really ugly, but it cannot give you division by zero. So how do we find the domain of a rational expression? First, you need to set the denominator equal to zero and solve. Whatever's in the top, whatever's in the numerator, ignore it and throw it away. You don't care about that. You're just focusing on the denominator. Once you have your answer or answers, you need to remove them from the domain. So first, find the domain of each rational expression. We have x minus 3 divided by 2x plus 7. I don't care about the top. I'm only focused on the bottom, and I'm going to set it equal to 0. And here I'm going to solve. Subtract 7 over. 2x equals negative 7, and then divide by 2. X equals negative 7 halves. And like I said before, it needs to be excluded or removed. So this is an answer we cannot have. So x cannot be negative 7 halves. So the domain of this, we can say that x is some value such that x is a real number and x cannot be negative 7 halves. So this is what's called set builder notation. It just states that x is a number and that it cannot be this, so anything but this. Next, x plus 10 over x squared minus 25. I'm going to just set the bottom equal to 0 and ignore the top. I can factor the bottom down to x minus 5, x plus 5. And then I can set each one of these individually equal to 0. So x minus 5 equals 0, and x plus 5 equals 0. And I can solve, and I'll get x equals, well, not equals positive 5, and x does not equal negative 5. So I actually have two answers this time that it cannot be. So the domain of this is x such that x is a real number and x cannot equal positive and negative 5. So just a little shorthand notation, so I don't have to write out both. Last, x squared plus 9. So x squared plus 9 equals 0. And this is the sum of squares. There's no way to factor it down. And there's no way to get a negative 9 because anything squared is a positive number. So this has no problems. So no numbers are excluded. So we can say that the domain is x such that x is a real number. And there are no exceptions in this specific one.